Hello, Pre-P Chemistry. How are we doing today? Hopefully y'all are doing well. Mr. Oglesby here. Today what we're going to be doing is we are going to cover net ionic equations. We call these NIEs. So let's go ahead and get started on this. Now, net ionic equations does still fall into the types of reactions unit, all right? And for this, what we're going to do is we're going to write out our equation, but then we're going to take into account some other things that y'all are going to need to know, okay? Those other things would be solubility rules. So you will need to know your solubility rules to know what's going on with your net ionic equation. Now, what are solubility rules? Well, the solubility rules are basically going to tell us what's going to happen when a substance is placed in water. Will the substance break apart into ions or will it not? And so that break apart into ions is will it dissociate, okay? And so when we're looking at this, that's something that we're going to be keeping in mind is our solubility rules when we need to know our net ionic equation, okay? Now, here are your rules. I'm going to go through each of these rules. These are rules that you need to know. So make sure that you've got those kind of locked into your brain, that you are ready to use those when we're talking about our solubility rules. So rule number 1 says all compounds whose cations are group 1 or ammonium. Now remember, ammonium is NH4 with a positive 1 charge. Everything that's got either something from group 1, so your metals over here, group 1, or ammonium, those are always going to be soluble, no matter what, okay? Which means if I've got anything from group 1 or I've got ammonium, then it will always be soluble, which would make it aqueous, right, because it would dissolve in water. Rule number 2 says all nitrates, chlorates, perchlorates, and acetates are soluble no matter what. So your nitrates, NO3, chlorates, ClO3, -1, perchlorate, ClO4, -1, and then acetate is C2H3O2, -1. So all of those are going to be soluble no matter what. So it doesn't matter what they're bonded with, they will always be soluble. Rule number 3 says if I've got a chloride, bromide, or iodide. So chlorides would just be something bonded with chlorine, bromide would be something with bromine, and iodide would be something with iodine. They are soluble unless they are paired with silver, lead, or mercury 1. So silver is Ag, lead is Pb, and mercury 1 would be Hg2 with a +2 charge. So as long as those things, chlorides, bromides, and iodides, are not paired with silver, lead, and mercury, they are soluble. The very last rule says that all sulfates, which remember sulfate is SO4 with a -2 charge, they are soluble unless they're paired up with silver, lead, mercury 1, but then also calcium, strontium, and barium. So as long as they are not paired up with silver, lead, or mercury 1, Hg2 + 2, calcium, strontium, or barium, they are going to be soluble. Now, if it doesn't fall into any of those rules, then we assume everything else is insoluble, okay? Again, if it doesn't fall into any of those rules, we assume that it is insoluble. Now, this is going to be, again, unless it says it's from group 1 or ammonium. Well, remember, group 1 and ammonium are soluble no matter what, okay? All right, so here I have lead 3 nitrate, and I need to predict whether or not this is going to be soluble or insoluble. So, thinking back at my rules, rule number 1 says if I've got anything from group 1 or ammonium, it is soluble, no matter what. Okay, so anything from group 1, that's going to be a metal. So that's going to be lithium, sodium, potassium, rubidium, cesium, francium. You can also have hydrogen there. Those are going to be soluble. Now, do I have any of those? No, I don't. Do I have ammonium, which is NH4? No, I don't. So it's not any of those, okay? So rule number 2 says all nitrates, chlorates, perchlorates, and acetates are soluble no matter what. So do I have a nitrate, chlorate, perchlorate, or acetate? Yes, I do. I've got a nitrate. Nitrates are soluble no matter what. So I would put that this is soluble. Now, if I were writing out this formula, I would have lead and I would have nitrate. Don't forget that since it's ionic, we do need to swap drop reduce. So lead has a +3 charge, nitrate has a -1 charge. So then we would get this as our formula. So if I wanted to show that this was soluble just with my formula, I could then put it in parentheses and put that it was aqueous. And that would also tell me that this is a soluble substance. Okay? All right, let's take a look at another one. So here I've got ammonium sulfide. So again, I think about my rules. Do I have anything from group 1 or ammonium? Well, yes, I've got ammonium, right? I've got ammonium. Well, they are soluble no matter what. So this is a soluble substance. Okay, it doesn't matter what else is there. We know that this is soluble because it has ammonium in it. Okay, now if I wanted to write the formula, NH4 would be ammonium. It's got a +1 charge. Sulfide would be S. It's got a -2 charge. So we'll put this in parentheses and we'll put a 2 there so that when we swap drop reduce, we're canceling out those charges. Again, I know this is soluble, so in parentheses here, I could do a Q. Okay. All right, so what I want y'all to do now is I want y'all to solve the next 2. So I want you to solve sodium iodide and cadmium fluoride. I want y'all to solve those 2 and decide whether or not they are soluble or insoluble. And then I also want y'all to write the formula and put that there as well. Okay? So pause your video, work those 2 problems, and then we'll go over them. All right, so I worked this first one. I've got sodium iodide. I did find that it was soluble because it had something from group 1. And then I wrote the formula, which was NaI. And then since it was soluble, I would put AQ down in the bottom corner. I also had y'all work this one over here on the left, which was cadmium fluoride. So what I found was that cadmium fluoride was insoluble. Now, why is it insoluble? Well, it's because it didn't meet any of my rules, right? There's not anything from group 1 ammonium. There's not a nitrate, chlorate, perchlorate, or acetate. There is not a chloride, bromide, or iodide. There is not a sulfate. And since none of those rules apply, we have to assume that it's insoluble. Now, since I'm assuming it's insoluble, then I would say, okay, I've got cadmium fluoride. There's my formula. And then I would say that it's a solid because it would basically be something that would not dissolve. Okay? All right. I'm going to leave these next 2 problems for you to do as practice. But we're going to go ahead and move on with our notes. So now that I know how to figure out if something is soluble or insoluble, I can start to look at my net ionic equations. So the very first thing that I need to do for a net ionic equation is to write out my formula. Okay, so write out that molecular equation, write out the equation that tells me, okay, I've got sodium plus chlorine and that produces sodium chloride, right? So I'm going to be writing out my molecular equation. It doesn't necessarily need to be balanced to do my net ionics. Okay. The next thing that I do is I'm breaking it apart into its ions. So I'm separating everything out into the parts that build it up, the different ions that build that up. Now, a net ionic equation is basically showing us what is happening throughout a reaction. And so as we're breaking apart things, we're going to see, okay, well, this didn't change throughout the reaction, so it wasn't really a part of the reaction. Nothing really occurred when I used that substance. And so because of that, we would call that a spectator ion, okay? Versus some substances like sodium and chlorine, those do react. We know that we take sodium, we take chlorine, and when they go through a chemical reaction, they produce sodium chloride, right? And so because of that, we do know a chemical reaction did occur, okay? So again, first step is to break everything up into its ions. Now, to do that, what we're going to be thinking about is, first off, did we follow our solubility rules? So you think back at your solubility rules and remember that, okay, well, solubility means that if I've got something from group 1 or ammonium or nitrate, chlorate, perchlorate, or acetate, or a halide, so chloride, bromide, or iodide, or a sulfate, those are all going to be things that fall into your solubility rules. So you're going to look at that and see, okay, well, is it soluble? So do I break it apart into ions? The other two things that you need to keep in mind are, is there a strong acid or a strong base? Okay. Now remember, your acids are going to be things that start with hydrogen, and your bases are going to be things that end with hydroxide. Now that is kind of a generalization, but for y'all, for the purposes of this class, those are the two big things to keep in mind. So how do I know if it's a strong acid or a strong base? Well, the easiest way is to think about the ones that are always a strong acid or always a strong base, based off of their name. Okay, and so there are 7 different elements, or 7 different compounds, 7 different acids that are classified as strong acids. And so as long as they are classified as a strong acid, you will break them apart. Okay, otherwise we were going to assume that they are a solid. For your bases, there are more bases, but there's an easy way to show them, so I'm gonna go through that. Okay, so to recap what I just said, because I know that was a lot. When I'm doing my net ionics, the first thing I need to do is look at my molecular equation. Okay, get that written out. The second thing I need to do is break everything apart into its ions if it is either soluble or a strong acid or base. Okay, so that's essentially what I said in much fewer words. So how do I know if something's a strong acid? Well, since there's only 7, it's easier just to memorize those 7. So those 7 are hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid, chloric acid, and perchloric acid. Okay. I've always remembered this as so, no, clo, brickle. That helps me remember those 7 different compounds, those 7 different acids that are strong. Okay, and essentially, so would be SO4, no would be NO3, clo, the first one would be ClO3, clo, second one would be ClO4, and then we've got bromine, iodine, and chlorine. So those would be the 7 different substances that would form a strong acid. Now, how do I make them an acid? Well, remember, acids are going to start with that hydrogen, right? So HCl or HI or HBr. Or if I've got the perchloric, then it would be HClO4. If I've got sulfuric, it would be H2SO4. Now, again, I would know that that needs to be H2 because we'd have to swap drop reduce. Okay, so those are the 7 different substances that form a strong acid. Strong bases I find a little bit simpler because for strong bases, basically we just look at group 1 and 2 on the periodic table, and that's what's going to help us decide if it is a strong base. So your strong bases are going to be anything from group 1 or group 2 on the periodic table bonded with that hydroxide. So something from group 1 would be sodium, right? And so that would be sodium hydroxide. That would be a strong base. Something from group 2 would be strontium hydroxide. That would be a strong base. So when we're looking at our hydroxides, if it's got something from group 1 or group 2 on the periodic table, then it's a strong base. Now there are some exceptions. The first one in group 1, so hydrogen, that is not going to form a strong base. Why? Because if I have a hydrogen and I add a hydroxide to the end of that, what is that? That is water. And we know that water is not a strong base, right? Okay. The other 2 are beryllium and magnesium. So how I've always remembered my strong acids versus my strong bases. First off, acids and bases. Acids start with hydrogen, bases end with hydroxide. For my acids, I remember sono, clo, brickle. For my bases, I remember that everything in group 1 except for the first 1, and everything in group 2 except for the first 2. And so that's how I've always remembered it. So everything in group 1 would be with the exception of the first one, so hydrogen, would be lithium, sodium, potassium, rubidium, cesium, and francium. And then for group 2, everything except for beryllium and magnesium. Okay, so once we recognize if it is either a strong acid or base or a soluble salt, which would be following your solubility rules, then we can actually break everything apart that is soluble, okay, which means all of those things. Now, something to keep note of. First off, we do not ionize molecular compounds. So those covalent compounds, we don't ionize them. Why? Because there's not any ions to ionize. And so if I've got stuff like water or gases or organic molecules, I'm going to leave them as a molecule. I'm not actually going to break them apart. Okay? The very next thing that we do is we're going to remove all our spectator ions. And I talked about this a little bit earlier, but basically those are going to be the things that are remaining unchanged throughout the reaction. So we look at the reactant side, we compare it to the product side, and if we don't see any change, then we're going to assume that that is a spectator ion. Okay? So now what we're going to do is we're actually going to dive into actually using all those rules. Okay? Okay, so now we've got our rules done. So let's take a look at actually solving a problem that uses these net ionic equations, okay, using your solubility rules. So really, all those steps, all that stuff that we had on the last page, those 4 things to do, it really comes down to really 3. And those 3 are, first, write your complete reaction. So that's going to be doing your predicting the products thing that we've done the last couple of classes. The second thing would be to write your complete ionic reaction. So the complete ionic reaction is going to be where I take the substances that are in that reaction, and anything that's soluble is going to be broken apart into its ions. Now, we don't do that with covalent, right? Because there's no ions there. During that step, once you've broken everything apart into ions that needs to be broken apart, you're going to look through and see if there's any duplicates. So you'll look on the left and look on the right side of that equation. And if there's duplicates, then you cross those off. Those are, again, what we call spectator ions. Once you finish that, the last step is going to be write your net ionic equation. So the net ionic equation basically involves everything that did not get crossed out as a part of your complete ionic reaction. Okay? So let's actually go through a problem and do that as a group. So here it says solutions of silver nitrate and hydrochloric acid are mixed. Well, the first thing is this word right here is actually really important because it tells us that both of those substances are already aqueous. They've been made into solutions. Remember, aqueous just means dissolved in water. So here I've got solutions of silver nitrate. And so I have silver and nitrate. It is an ionic compound, so I would need to cancel out their charges. Silver's a +1, nitrate's a -1, so they do already cancel out. And they tell us they're solutions, so I can go ahead and label that as aqueous, AQ. Next, it says solutions of silver nitrate and hydrochloric acid. So hydrochloric acid is HCl. And they tell us it is a solution, so this is also going to be aqueous. And then they tell us they are mixed together. Well, this is a double replacement reaction. So in double replacement reactions, we know that we put the inside with the inside and the outside with the outside. So silver's going to pair up with chlorine, nitrate's going to pair up with hydrogen. So we get HNO3 and AgCl. They've all got plus or -1 charges, so they do already cancel out, which means this is already balanced for us. Okay, so now what I need to do is I need to decide whether or not HNO3 and AgCl are aqueous. Okay, so I need to decide if they are going to be soluble. How do I do that? Well, I think about my solubility rules. First off, looking at my HNO3 here, this starts with hydrogen, right? Well, again, what I told y'all is that if something starts with hydrogen, it is probably going to be an acid, right? And so I'm going to assume this is an acid. So if I assume this is acid, then what I need to do is I need to think about, okay, well, is it a strong or weak acid? And what I told y'all is that there are 7 different strong acids. And those 7 strong acids are the acids that you need to memorize because everything else is going to be weak. Okay, so I need to know if this is a strong acid. What I told y'all for your strong acids is so, no, clo, brickle. Br, and then I, and then Cl. Okay, so I have sulfate, nitrate, chlorate, perchlorate, bromide, iodide, chloride. So do I have hydrogen with any of those 7 things? Well, yes, I do. I have nitrate there. And so since that is there, we know that that is a strong acid. And so since it's a strong acid, it's going to be aqueous. Okay? Well, then I'm going to do the exact same thing with my silver chloride. So I look at this. Is silver chloride an acid or a base? It's not an acid because it doesn't start with hydrogen. It's not a base because it doesn't end with hydroxide. So if that's the case, then we need to think about, okay, well, if it's not an acid or a base, the only other thing we talked about was a soluble salt. So remember, anything that's ionic is considered a salt. So this is an ionic compound. So I'm going to assume it is a salt, which means I need to think about my solubility rules. Well, remember that anything from group 1 or ammonium is soluble no matter what. Okay, so looking at my compound here, do I have anything from group 1 or ammonium? No, I don't, right? So those would both be in this first slot where the cation would go, but they are not. So not one of those. The second one says all nitrates, chlorates, perchlorates, and acetates are soluble no matter what. Those would go here on the chloride section right there. So do I have a nitrate, chlorate, perchlorate, or acetate? No, I do not. I have a chloride. Okay? The next rule says all chlorides, bromides, and iodides. Okay, well, wait. Yes, I've got a chloride here. So we're going to be looking at that rule. So chlorides are soluble unless they're paired up with silver, lead, or mercury 1. Is this paired up with silver, lead, or mercury 1? Yes, it is. And so since it is paired up, it is insoluble. And so we will put a S right there. Okay. And basically what that tells me is that that did form a precipitate as a part of that reaction. Okay. So now I've got my complete reaction finished. Now let's take a look at our complete ionic reaction. So the complete ionic is basically anything that was aqueous, we break apart into its ions. So first off, I've got silver nitrate. That was aqueous, so it's going to separate into the silver ion and the nitrate ion. Okay. Then I have hydrochloric acid, HCl. That's going to separate into a hydrogen ion and a chloride ion. Good there. Moving on. I have HNO3. That was aqueous, so it's going to separate into the hydrogen ion and a nitrate ion. And then last, AgCl, it is not aqueous, so we leave it as it is. Okay? So that would be my complete ionic reaction. So before I can actually move on, one thing I need to do is go in and separate out all my ions. And anything that is going to be duplicated on either side, we cross those off. So those would be what we call our spectator ions. So first off, let's start with silver. So silver as a reactant was an ion, and as a product is a part of a compound. So did it change? Yes, it did. Nitrate is an ion on the reactant side, and on the product side, it is still an ion. So did it change? No, it did not. So that is a spectator ion, which means it did not participate in this reaction. Next, we look at our hydrogens. Hydrogen's an ion on the reactant side. It's an ion on the product side, so we can cross that off as well. Chlorine is an ion on the reactant side, but it's in a compound on the product side, so it did change as a part of that reaction. Okay? So really the things that participated are silver, chlorine, and they formed silver chloride. Okay? Now here's something I will say as a side note. If you actually go through and cross off every single thing, because on the reactants and the products, everything remained unchanged, then your net ionic reaction would be what we call no reaction. And so you would just write no reaction for that, okay? Okay, so now let's actually do our net ionic reaction. So the net ionic reaction, all I need to do is look at my complete ionic reaction and write down anything I didn't cross off. So I have silver, which had a positive charge, and chlorine, which had a negative charge, and they produced silver chloride. And that's it. That would be my net ionic reaction, okay? Now, this very last thing that I've got here is called a particulate drawing. And all a particulate drawing does is it looks at the individual particles, and it's showing it's a representation of what happened in the reaction. So let's walk through this one. So I started with a beaker. I know that's not really a beaker, but you get what it is. So I started with a beaker here, and in this first beaker, I had silver nitrate. And they told me it was a solution of silver nitrate. And so in this, I will have the silver ion and the nitrate ion. Okay? I also have, that's a better beaker. I also had another beaker that had hydrochloric acid in it. So it was H with the positive ion and Cl with the negative there. Okay? And we combined those in a larger beaker. Let's see if I can do a good one this time. Not bad. And we go across right there. And inside of this one, looking at our complete ionic reaction, what we saw is that the hydrogen and the nitrate were both spectator ions. So what that tells me is that they didn't react. And so I have the hydrogen ion floating around and the nitrate ion floating around. But I also had chlorine and silver, right? They did participate in this reaction. And so since they participated, we need to make sure we recognize that. And so we know that they turned into a solid. And so I'll show that. So I have a solid of silver chloride in the bottom of that beaker. Okay, and so that's all that is signifying there with that particulate drawing. It's just showing, okay, I started with two ions, the silver nitrate in that first beaker, and a hydrochloric acid, the hydrogen and the chlorine ions in the second beaker, and I combined them into a third beaker, and I got two ions, of hydrogen and of nitrate, and then I had a silver chloride that formed as a solid, so it sunk to the bottom there. Okay? And that would be it for your net ionics. So here's what I want y'all to do. I want y'all to actually go through and solve this next problem, okay? Use a reference or use question 1 as a reference for you while you're working through this. But I want you to solve all of this with your video paused and then replay the video and we'll go over it, okay? So pause your video, solve the problem, and then we're going to go over it. All right, y'all, so here is your reaction that occurred as a part of this lead acetate solution being stirred into that sodium chlorate solution. So first off, I went lead acetate and sodium chlorate, and I wrote their formulas there. And I do know that those are both solutions because they told me that. So we do know that they are aqueous. And then we went through this double replacement reaction, and we produced lead chlorate and sodium acetate. Because we swapped their partners. Then I checked my solubility rules, and I found that both of those were aqueous. Okay? Then I did my complete ionic reaction, and so I separated out everything that was soluble, aqueous, into its different ions. So lead acetate turned into Pb plus 2, and C2H3O2. There were two C2H3O2s, so I did signify that with a 2 in the front there. Sodium chlorate turned into Na with a plus and ClO3 with a minus. There are 2 of each of those because of the coefficient they had. Then I turned that into lead chlorate, which was Pb plus 2, and that turned into plus 2ClO3 minus, and then I have Na plus and C2H3O2 minus. So then the next thing I went through and did was I crossed off anything that was a duplicate. And so I had lead on both sides, I had acetate on both sides, sodium on both sides, and chlorate on both sides. And so since it was the same on everything, then my net ionic reaction is just no reaction. Okay? Last thing is that particulate diagram, and basically all I'm doing is I'm showing those ions floating around. So I had 1 lead and 2 acetates in that first one. And then in the second beaker, I had 2 sodium and 2 chlorates. I know that because of that coefficient, right? And then basically because there was no reaction, everything just gets dumped in. So there's 1 lead, there's 2 sodiums, there's 2 chlorates, and then there's 2 acetates. So basically I just added it all in there. And so that would be it. So that is net ionic equations. And I know that it does take a little bit of time to get these through, but they are pretty simple once you kind of break it down into its parts. All right. Y'all let us know if you've got any questions. But otherwise, I hope y'all have a great rest of the day. Bye, y'all.